Hello everybody, I'm feeling much improved from yesterday. I looked at the quizzes, there's some good, there's some bad, but that's why we do it. So don't despair if you didn't get like number 2 or number 3 right. That's what this is for. I'm going to go over some solutions, we'll clear some stuff up, and you're going to do great when the quiz when the test comes like a week and a half from now. So problem 1, most people did pretty okay on this, so let's just go through this one quickly. Here, limit x approaches infinity. It looks like as x gets very large, y values are approaching -3. Here, as x approaches negative infinity, as the x values are going this way, the y values seem to be going up forever. So my favorite answer is increasing without bound, but I would also accept positive infinity. Here, limit as x approaches 6. Well, the problem here is it depends on which side. So as you're getting closer to 6 from the negative side, the limit is 1. As you're approaching 6 from the positive side, it looks like it's getting closer and closer to -1.5. So in order for the overall limit to be defined, the left-hand limit and the right-hand limit have to be approaching the same value. So this one would be does not exist. However, as I just said, from the positive side, it looks like we're approaching -1.5. Limit as x approaches 1 is right here. And again, this is not defined. From the left-hand side, we're approaching infinity. From the right-hand side, we're approaching negative infinity. So you couldn't actually write increase without bounds or decrease without bounds, because the problem is from the left, it's increasing without bound, but from the right, it's decreasing. So because this one isn't saying from the left or from the right, we can't say either. It just doesn't exist overall. Here we're saying what happens when we approach 1 from the negative side, and that's increase without bounds. Here as x approaches -5, from both sides, it looks like y values are getting closer to 0. And then here, -5 from the positive side, again, it seems like we're approaching 0. All right, so let's look at this one. Here we have to figure out, is it odd or even or neither? So like I said in my introduction to class video, you do need to know what these algebraic tests are. So even would mean it's got horizontal reflection symmetry. And if you write that algebraically, we're saying the untransformed function should be the same as if you flip it horizontally. And so that -x on the inside is the horizontal reflection. So let's actually plug in f of x and see if this equation is true. So on the left-hand side, we've got 5 over 2x cubed times x squared plus 1. And we're going to see, is that the same as if we substitute in -x? So we've got 2 times -x cubed times -x squared plus 1. So if I've got -x cubed, that's 3 things that are negative being multiplied. So that I can take that negative sign out, and I've got just -2x cubed. Here I've got -x squared, which is the same thing as x squared. And so I can see that these two sides now are not equal, because here I've got a positive, and here I've got the negative. So that test has told me that it is not an even function. That test actually would be enough to convince me that it was an odd function, if you think about it, because this is the test for being an odd function. We're saying that the untransformed function is the same as if we flip it horizontally and vertically. Notice the only difference between the even and odd test is this negative sign on the outside. So you'll notice that here we ended up getting f of x exactly, but with this negative sign on the outside. So even without plugging it in, that's enough for me to see that it's the same as odd. But let's just plug it in and confirm it for ourselves. So here I've got 2x cubed, x squared plus 1. So that's the untransformed function, and I want to know, is that the same as the opposite of what happens when I substitute in -x? So that's -x squared plus 1. So just like last time, this -x that's being squared, the negative signs cancel each other out. Here I've got 3 negative x's, so that brings the negative to the outside. So I've got this negative is here, and then I've got I've got -x cubed. And now this negative cancels with that negative to give us my original function. So that's worked because I see that both sides are the same. So that means when I apply these two transformations and I change it algebraically, I can see that it's really equivalent to the original. So that's how you can conclude that it's an odd function. Okay, so last one. A lot of people just plugged in h and they got, let's see, square root of 9 is 3 minus 3 is 0 divided by 0, and they said something like 0 over 0 is undefined. But those people are just, they're not thinking about what does limit actually mean. Remember, a limit is about what happens when h gets closer to 0. So if you just plug in 0, that hasn't really told you very much, because undefined values aren't values that don't exist or that are an indication that something went wrong in the problem. They're literally undefined. Like, we don't have a definition for them. But the limit could still exist, because what's really happening here, if you were going to graph this function, is there's a hole at h equals 0 in the function, but it actually has a well-defined limit. Like, on both sides of the hole, the function's approaching a specific value. So the whole exercise here is being able to algebraically restructure. That means algebraically simplify until you can figure out what would fill in that hole. So in the practice problems, I'd suggested that you apply the conjugate. The conjugate is the square root plus 3, whereas this is the square root minus 3. And the reason you do that is because you can get rid of the root in the numerator. So let's write that, and then I'm going to multiply it by root 9 plus h plus 3 over root 9 plus h plus 3. And look what happens when we multiply this out. So the square root times the square root undoes each other, so that's just 9 plus h. Then we've got plus 3 times the root, and then we've got minus 3 times the root. So those cancel each other. And then we've got minus 3 times positive 3 gives us negative 9. Very nice. Then here in the denominator, I've got h times each of those terms. So I've got h times root 9 plus h, and then I've got plus 3h. So now the question is, has this really helped us? Like, clearly we've got 9 minus 9, and those are going to cancel each other. Oh, this is nice. So now we've got h in all the terms, so maybe I shouldn't have even distributed the h, because if I factor the h back out again, now I've got in the denominator h times root 9 plus h plus 3, because I took the h out of both terms, and in the numerator I've got 1h, so those are going to cancel each other, leaving 1 in the numerator. So now let's ask the same thing. This is not a new problem. This algebraic equation is equivalent to the old one. All we've done is filled the hole. So let's see what happens when we plug 0 in. Now we've got 1 divided by, let's see, this is going to be root 9 is 3 plus 3, so that gives us 1/6. So that's the exercise. On the real test, it might not look exactly like this, and the trick might not be multiplying by the conjugate. Maybe it would be a different trick. We've seen where you have to like combine two fractions under one denominator. We've seen where you might have to multiply out a numerator in order to cancel. But it's definitely going to be one of the tricks on that list of 9 problems that you worked on over 2 days of class. And those are on your independent practice with solutions. So just make sure that you're cool on all of those problems, and you'll be good for the test. Okay, I hope this was helpful. If it wasn't and you want me to talk in more detail about like any of the details in here, please let me know.